Welcome to qnawire.
Problem 7.45. We have a stone rolling down a hill that's snowy. It then slides along a rough patch of ground until it goes a distance of 100 meters before it hits a light spring that's long with a spring constant of 2 newtons per meter. So first we want to find what is the speed when the stone enters the rough area where friction begins to happen. What is the maximum compression of the spring? And then given the spring force that's exerted and the static coefficient of friction, will the stone move again after the spring stops it, after reaching the maximum compression of the spring? So here, this is a fairly straightforward conservation of energy thing. We know that it starts off with, if we call this direction y, it starts off at 10 meters per second. We use conservation of energy. It gets to height b, so everything is kinetic, and then those things are all equal to each other. So 1/2 mva squared, because it is moving initially, plus mg ya has to be equal to 1/2 mvb squared. So let's see, m's all cancel, get a 2 there. So then VB is equal to the square root of VA squared plus 2G y sub A. This will be 22.22 meters per second. B, more conservation of energy, but now we have friction adding an other work. So the potential energy here from gravity is all going to be 0. So there's no potential energy to begin with, so there's just kinetic. So we'll have 1/2 mvb squared. Friction is going to do work equal to the kinetic coefficient of friction times the normal force times the distance across here, which let's call d. The normal force is just the weight because this is horizontal. Okay, mg d. And then this is going to be equal to, because it will come to a stop, so the only energy is going to be potential energy that's elastic and that is stored in the spring. So 1/2 k x max squared. So we know all of these things except for x max. So we find that x max will be the square root of, can factor an m out, we have a vb squared minus 2, so we're going to multiply everything by 2, U sub k GD. And then we can put all of these things in, recalling that this is our 100 meters. And we find that the compression will be 16.4 meters. Oh, yes. No. Well, that is what it will be, but everything I just said is mostly true, except the friction still applies while the spring is being compressed. So in fact, we end up having to solve a quadratic equation because now we have x squared and x. Sorry about that. So this ends up being compressed by 16.4 meters. So when it says that it is a long spring, it means it. And so now C, will the stone move after the spring stops it? So we know that the force the spring it can exert is kx. And so then this is our 2 newtons per meter times our 16.4 meters equals 32.8 newtons. And the static friction force is less than or equal to mu times mus times the weight of the object. Since this is horizontal, the normal force is just equal to its weight. And so that gives us 118 newtons. So the box will stay at rest because it would take at least 118 newtons that the spring is exerting on the box for it to start moving again. And 32, 33 is less than 118. So box stays at rest.